Assalamualaikum. So today our group will be presenting our project for DSC650. So our project is titled Socioeconomic Drivers of Crime in Malaysia. In this project, we take a data-driven look at how poverty and district level crime are connected and how machine learning can help guide smarter resource allocation for law enforcement. So this project was carried out by our group under the supervision of our lecturer Wan Saiful'azzam bin Wan Ismail. Let's get started. So let's start with why we did this project. Economic hardship and public safety are deeply connected issues, but they are rarely studied together in a structured way. So our aim was to build a full data pipeline starting from raw government records all the way to a predictive model to explore how poverty relates to crime across different districts in Malaysia. We use Python throughout the whole process. Tools like Pandas and scikit-learn for handling the data and visualization libraries for presenting our findings. We merge data from national census, economic source and police record. In total, our dataset cover 116 districts using data from 2020 and we look at two different poverty measures, absolute and relative poverty, to get a more complete picture. Now, what's the actual problem we are trying to solve? Right now, police and municipal resources are still allocated reactively based on crime history and general hunch, rather than on solid socioeconomic evidence like poverty levels, unemployment or income disparity. This is a real problem because it means vulnerable communities can end up under patrol while resources go to areas that don't need them as much. Our approach is to analyze these underlying socioeconomic variables and build a predictive model, essentially helping shift decision making from reactive to proactive and from guesswork to a data-driven strategy. And then I will pass to the next presenter.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Moving on our objective, which is we have five main ones. So first, to analyze the dataset and identify key patterns linking crimes distribution to poverty level across Malaysia district. So second, to implement a proper data pre-processing and cleaning techniques since we had to merge several different government datasets. So third, to apply suitable machine learning algorithm to build a predictive model for crime rates. And fourth, to visualize both the data and our model output so our findings are easy to interpret. So last but not least, to draw a meaningful conclusions and suggest actionable insight based on what we found. Let's move into the next slide, which is we have data source and descriptions. So for our data, we rely on two trusted government sources, which is first data.gov.my for a crime data by district from the Royal Malaysian Police and the Department of Statistics Malaysia DOSM for poverty data by district covering both absolute and relative poverty rates. Because these are official open data portal, we can be confident that the data is accurate and reliable. So in total, we work with 116 district level record from 2022, a year that especially relevant because it is represents a critical period of economic recovery after the pandemic. So our data sets include five key indicators, which is the first one, which is state, second district, third total crimes, fourth absolute poverty rate, and last relative poverty rates. Okay, next, let's walk through our methodology, which followed 7 main stages. Okay, we started with the data collection, gathering crime and poverty data from our 2 sources, and then we moved to processing, filtering the data to only 2022 and removing aggregates all rows, and merging both dataset using the districts column as our key. After that, we perform exploratory data analysis or EDA to understand that the structure of our data and uncover initial patterns. So next was feature engineering. We will apply standard scalar to standardize our poverty rates percentage before feeding them into the model. And then came model development, where we apply machine learning algorithm to build our predictive model, followed by model evaluations, where we assessed its performance using RMSE and R-squared. So finally, we visualize both the data and the model's output to present our finding clearly. Thank you.
Thank you, Muhammad Adib. Next, we move to slide 7. Now, let's talk about the machine learning algorithm we chose. After careful consideration, we identified multiple linear regression as the most suitable algorithm for our problem. We chose this because it's able to predict a continuous target variable. In our case, total crimes based on multiple independent variables, which are our absolute and relative poverty rates. More importantly, it gives us highly interpretable coefficients which let us clearly explain the cause and effect relationship between poverty and crime. This mattered a lot to us because our audience includes policymakers, and interpretability is more valuable here than just a raw predictive power. We built this model in Python using scikit-learn with our poverty rate features standardized using standard scalar before training to keep the coefficients comparable. We evaluated the model using 2 metrics root, mean squared error, or we call it as RMSE, and R-squared. Next, we move to slide 8. Let's look at what we found. On the left, this is our correlation heat map. It shows a moderate negative correlation between poverty rates and total crime count, meaning districts with higher poverty don't necessarily have the highest crime numbers. On the right, our scatter plot support this. It shows that major crime hotspots are actually concentrated in districts with lower absolute poverty percentage, which are likely more populated urban areas. So, to conclude, overall, this early exploration already hints that poverty alone might not be the main driver of crime, which leads us into our model results.
Thank you, presenter Ahmad Firdaus. For next slide, I'm going to go for model performance. Now, for our model's actual performance, our root mean square error, or RMSE, was 570.37, and our R-squared score came out to 0.0658. On the right, you can see our actual versus predicted crime counts plotted together. The red dashes line represent a perfect prediction, and you can see our model's prediction in blue, which doesn't follow that line very closely. This tells us the model explanatory power is quite low, which is actually an important finding. It's not just a weak result. So in conclusion, what does all this mean? We can put together, which the R-squared only 0.0658. We can conclude that poverty is not the main driver for the crime in a district. And more importantly, we doesn't see this is a limitation of our project. From a data analytics perspective, These actually meaningful findings. This is a tell us that crime is a multifaceted problem shaped by much more than just economic hardship. There are likely other important factors we didn't capture in this data set. Things like population density, urbanization, presence of law enforcement, localized unemployment, and education level. Moving forward, we recommend extend this pipeline more granular data like census information, unemployment rates, education data to build a richer and more comprehensive model that can support predictive policies, urban planning, and also strategic resource management. That brings us to the end of our presentation. To summarize, we successfully built a full data of pipeline from data collection all the way to a working predictive model. And along the way, we learned that poverty doesn't explain the crime, which redirect the conversation toward other important socio-economic factors. Thank you for listening.